Power Forward, Phase 2, Day 2, I believe we are officially over the hump. If Phase 3 is 3 days, I believe we are over the hump on Power Forward. So, congratulations, one and all. They said we'd never even get this far. I'm kidding, no one said that. We are more than capable of handling this proceeding. We are going to hear this afternoon from our electric distribution utilities. We're very excited to have each of them represented. Those panels will go till about 4:30. And then, are we done for the day after that? Okay, so we've got our 4 EDUs this afternoon. I have to read a statement because it is in fact our EDUs that are going to be presenting. Bear with me, you know the deal. So, I would like to thank each of the electric distribution utilities for participating today. I already said that, actually, so I'm ahead of the game. We understand that each utility has a pending case before the Commission which touches at some level upon the policy issues we are discussing today and throughout Power Forward. We ask every presenter who is a party to one of these cases to please avoid discussing the facts of specific cases or making specific arguments advanced in those cases. It may be unavoidable to discuss policy issues today which touch upon specific cases, and if that happens, the Commission will make the appropriate disclosure in each case, and the video for Power Forward will remain available for all parties to review. Having said that, let's begin. So first up we have, I believe we are starting with Scott Osterholt. He is the Director of Grid Modernization and Risk Management at AEP Ohio. Thank you very much, Scott, for joining us today.
Yeah, thank you as well, Chairman Hawk, and as well to the commissioners. So AEP is very appreciative of you guys giving us a chance to share our perspectives. I'll start off by saying AEP Ohio has been very supportive of the grid modernization efforts. We feel like it's a natural evolution for the utility, and it drives a significant amount of benefits for our customers. So to start the discussion, I'd like to go backwards and kind of share a little bit about our experience with smart grid technologies. So back in 2009, we started our Grid Smart or Smart Grid Phase 1 project. And you'll see that the project wasn't as robust as others across the nation, but what we had was a project that threw a lot of different new technologies all in the same geographic area. And what this was is a learning opportunity to understand what the benefits of these technologies are and what are the best things for us to move forward. So you'll see AMI, we're not talking millions of meters back then, we're talking 132,000 meters, 17 circuits of volt bar optimization, and 70 circuits of distribution automation. So that kind of became our framework for our learning and our understanding about the smart grid technologies. I'm pleased to represent that even though, again, the project wasn't huge, it was well received by our peers in the industry. So we got a few awards that I wanted to share, first being from EPRI. EPRI granted us with a technology transfer award. That was for moving the volt bar optimization technology from more of a trial and from a lab to a full production, as well as the industry recognized us in 2012 by the Power Grid International Smart Grid Project of the Year. So again, just showing that the project was well received. As far as experience basis for AEP Ohio and Smart Grid, obviously I talked about our initial project, but AEP has six other operating companies outside of AEP Ohio, and each one of these operating companies is also partaking in smart grid deployments. You'll see that from an AMI metering perspective, that we have across the AEP footprint, we have nearly 2 million AMI meters installed, and we have another nearly 1 million planned to go in service. As well, from the DACR and VVO perspective, from DACR, we currently, across the companies, we have 271 circuits in service. We have another about 3 times that many planned. And VVO is similar, 90 circuits in service and another 3 times that is planned to go into service. And we work closely with these other operating companies to talk about lessons learned, talk about vendor performance issues, and that becomes a basis for our smart grid understanding as well. So from these learnings, both from our Smart Grid Phase 1 project, as well as our other operating companies, we focused on what is those best technologies for the customer, What we've learned is AMI, Advanced Metering Infrastructure, or smart meters, distribution automation, circuit reconfiguration, and volt-VAR optimization drive the most benefits for the customer. And those are the three technologies that we requested approval to move forward with, and that approval was granted earlier this year in February. And we're actively working to move those projects, those technologies forward. We'll start meter installs later in August, and we'll start the distribution automation and volt-VAR optimization field work later in this year. As far as the AMI deployment smart meters, we plan to put these in the most condensed populated areas, as shown on the map there. We'll touch 89 communities, and these are the locations where we get the most benefits for the dollar deployed. At the beginning, I talked about the customer benefits and how important that is to a smart grid deployment. I'd like to go a little bit more in depth and talk a little bit about that. So for AMI, Advanced Metering Infrastructure, these meters obviously can do work that was traditionally done by a labor workforce. By putting these meters in, we're displacing that labor need, which equates to a utility savings. The typical way to pass that savings back to a customer is through a distribution rate case. What we agreed to in our Smart Grid Phase 2 project is we would pass that back near immediately by netting that against the rider, so the customer get that operational benefits as a savings to them in near immediate fashion. Distribution automation, we expect to see an improvement of the customer outage exposure by up to 30%. So that could equate to 21 million customer minutes of interruption saved per year for the customers. And if you use the DOE's Lawrence Berkeley National Lab study on what an outage hour is worth to a customer, and you monetize that, that could be as much as a $71 million benefit for the customers. And then for volt-VAR optimization, what we realized from our Phase 1 deployment is that there should be about a 3% voltage savings. And what that is it equates to a customer billing savings. So another, again, trying to paint a picture that these are very valuable from a customer perspective. When you take and you look at all those benefits together, look at it at a 15-year business case, what we found is you had about a $1.4 billion of benefit for the customers. $200 million approximately for AMI operational savings passed back to the customer, a little over $200 million additionally for the savings for volt-VAR, and a little over $1 billion in that reliability benefit to the customer. What I like to do is compare that against to the operational or the deployment cost. And what we found is that the benefit, the customer benefit far exceeds the deployment cost. In this case, for our Smart Grid Phase 2 project, that deficit or that improvement for the customers is more than $900 million benefit. Another way to look at that is for every dollar that we plan to spend on Smart Grid Phase 2, we plan to deliver about $2.80 of benefits to the customer. Again, trying to paint a picture of the value to the customer for these initiatives. A lot of companies are focusing on the environment, sustainability goals. I wanted to paint a picture here as well of how these smart grid projects help the environment. I'm not an environmentalist by background, so the carbon reduction in metric tons in the middle doesn't mean a lot to me, but the far right column on this chart is basically the equivalent of taking cars off the road. So this is just 4 top categories for our deployment, the operational savings, taking trucks off the road, then the energy savings. And what we found is, from history from our Phase 1 project, that the Phase 2 project should take off the equivalent of about 27,300 cars off the road annually. So again, a big environmental benefit as well. Back to the, customers are our focus, the customer perspective. We really want to use these smart grid technologies to enhance our customer experience. We think that the smart meter and these different technologies offer great benefits to the customer, and we really want to do a great job from end to end of delivering that message to the customer. So we planned out a substantial marketing and communication outreach to the customers to share these benefits, starting from before we start the meter through the meter install, and even post-install, sending them some marketing information that shares what the benefits are. And I'd like to go through a couple of those benefits. So I'll start off by talking a little bit about the interval data that AMI or smart meter provides. So in the old world, the only data that the customer got on their history, on their usage, or how much energy they use, is a 30-day view. Now with the smart meter, we're collecting information. We can deliver that to the customer in 15-minute increments. We think that's of value to the customer so they can look on a web portal, see a graph like this, and say, what am I doing differently on how I consume, in this case, in the middle of the afternoon? What could I do differently to change my behavior and conserve energy? We think that's the benefit here. We also think time of use rates are a benefit. We think they lead to overall lower costs, lead to lower energy consumption. And there's other things that we find value from our smart meters as well. Things like high bill alerts. We talked to JD Power, and one of the things that they said customers want the most is understanding what their bill is going to be before they get it. AMI data, we can collect that information, look at it between the 7th and the 15th day of the billing cycle, use that information to make some assumptions, look at whether that customer is on target to meet or exceed their previous year bill for the same period. And when they are exceeding it, we can communicate to the customer, again, targeted before the middle of the month, middle of the billing period, so they can make corrective action and work towards getting their bill where they want it to be. Again, all great benefits for the smart meters in our perspective. All the web portal information, we collect that data from the AMI meter. We collect it 6 to 8 times a day. We run it through our meter data manager overnight. We clean up that data. We post it on a web the next day. So all the web information is day behind. We think that there's value in making sure that the customer has an opportunity to see their energy consumption real time. So just recently we released a new app called It's Your Power. This app connects directly to the meter. It has the opportunity to look at 3-second increment data from your meter, aggregate it in 1-minute interval data, and post it on the app. So again, similar to the web portal, but we're in a scrolling world where people want information at their fingertips. They want to know what's going on right now, and they want to be able to take action. Just like the high bill alerts, this app also has the opportunity to look at whether a customer is on target to a budget that they can set. So in this case, shown on the screen, customer set a $40 budget. Looking at their first, looks like about 5 or 7 days of usage. It's projecting where they're going to be at the end of the month. This customer wanted $40. They're projected to be at 53, so they're off by $13. They can take corrective action. Again, these are the things that we think that the customers are wanting. Distribution automation, I mentioned earlier, our target of trying to get 30% improvement on the outage experience for the customers. We'll see that in twofold, one in the number of minutes of interruption as well as the number of interruptions in total. So from our phase 1 deployment, the 70 circuits, from 2012 to 2016, our safety improvement for those circuits was 16%. That's 120,000 customer interruptions that were avoided during that period. And then SAIDI, we had a similar experience, 11% savings. That's 10 million customer minutes of interruption that are saved. And since that's been deployed, it's been more than 12 million in total customer minutes of interruption saved. And these circuits were selected based on geographic reasons, not based on what are the best circuits to do. And that was one of the things that we learned from phase 1. So as we go into phase 2, we're going to pick the best circuits that derive the maximum savings for the customer, and we expect to reach those 30% targets. Obviously, with the distribution automation and volt-var optimization technologies, you need to build a back office system to support that. We built a robust new platform, a distribution management system. This management system integrates GIS, mapping data, outage data, as well as SCADA data, so that we can have a real-time view of what's going on in these new networks. We can take that information from the network. We can understand what's going on in the field. We can see real-time operations. We can see alarms when things aren't going as they're supposed to. We can dispatch trucks. We can gather the outage information into a centralized location, and we can, in the future, we'll be able to work through the system to understand what we can do to further optimize the system without relying on manual analyst work. So we talk about volt-var optimization, distribution automation. Obviously, we're talking about a complex system. I wanted to at least show you a little bit about the architecture to show how complex this system is. So I'll start off on the right on this screen and talk about the field devices. So you'll see, reclosers and switches are the primary field device in distribution automation, circuit reconfiguration. But as well, we're working where we can to automate the line regulators, capacitors. So we have a fully automated system where we can have visibility and we can do adjustments, from a remote location. In the middle of that slide is all the devices that are in our substation. Then on the left side is the distribution automation controller that will be placed in our IT network center. And then at the bottom, you can see the connection over to our distribution management system that I just talked about. For VoltVar, as I mentioned earlier, 160 circuits is what we plan to do for phase 2. We target to try to reach the maximum benefit for the customer for this technology as well. What that equates to is finding circuit locations that have the maximum loading. So the more loading, the more of that 3% customer savings benefit that you'll have, and that's what we're working to select for the phase 2 project. Similar architecture. The line devices on the right are a little bit different. The line regulators and capacitors, rather than just being something we monitor and control, they'll actually take action. Then the other new piece in this slide is the end-of-line monitors that are looking at that end-of-line voltage. And the VoltVar optimization controller will be in our IT network center as well. When you talk about complex architecture like we just talked through, it shows the need to have standards. Standards for interoperability as well. I'm pleased to talk about how our engineering group has developed 29 internal distribution technical standards that we operate. And those are the same standards that operate across all of our operating companies. And we have different technologies, different vendors, and it shows the importance of how they all play together. Our team is also working with other utilities, other vendors to advance standards and interoperability as well. And probably the thing that's most interesting is we are contributing with other groups like IEEE and EPRI who are developing standards for the industry, and we're sharing our insight on what we've learned from our projects and adding to and collaborating with them on their standard development. When we talk about a smart grid system, one of the key pieces is how do you communicate with those devices? So what is your telecom system? I'm pleased to say that we have a very robust communication system. We have a very large fiber optic network that connects a lot of our offices, substations, and that is the backbone. We also have a large SCADA system, and recently we've been working to enhance that SCADA system by adding more nodes, which effectively creates more redundancy in the system. But from a smart grid perspective, those end-of-line devices that are typically communicated via wireless signal, there's 3 main initiatives that we've recently been taking on that are improving that communication. First one is we're working to use the latest encryption technologies, protocols such as IPv6. We're also monitoring our system, our telecom system, 24/7, both from a telecom perspective as well as from a cybersecurity perspective. And then the last thing we're working on is we're working to transition over to more of the LTE networks, public and private. So we're looking into how that private LTE option would work to be a good communication provider or good communication service for our technologies. So I talk about a lot of new nodes, a lot of new wireless devices out in the field, computerized. So obviously that brings up the importance of having a robust cybersecurity program. So if you look across the news of any week, I always feel like there's always something on there about some type of breach. So there's many different things that are going on out there. There's lots of things such as, things that we don't want to deal with, such as the advanced threats with the electric grid in some of the other countries. We also there's new threats with activists wanting to cause distractions. And our cybersecurity team is monitoring that environment because it changes nearly every day. They're also working with us what they're calling layered and segmentation. So if a hacker was to get into our network, what can we do to minimize what they could do? The team is also working from day one on our projects. They are involved, with the vendor. They're working to find risk and mitigate them before we put these things in service. As soon as we are done put things in service, they're still doing ongoing penetration tests, kind of white hat kind of penetration tests, to see where there's ongoing or new vulnerabilities. And the last thing is to kind of bring it full circle is, again, you got to focus on what's going on out in the world. And one of the best ways we found to do that is be participants in a lot of different user groups, whether that's industry user groups, vendor user groups, hear what other people are experiencing so that you're ready to deal with those things. And the last thing I want to talk about today is smart street lighting. So as we work to deploy an AMI network for our Grid Smart Phase 2 or Smart Grid Phase 2 project, we're deploying the latest Generation 5 hardware from Silver Spring Networks. That new system, Gen 5, has got a lot more robust capabilities, a lot more hardware, a lot more memory, a lot more physical capability. What we're trying to understand is, could we end up and put a smart street lighting system on top of that AMI network without deploying another new communication system at all? We're even to the point where we're wondering, could that AMI wireless communication system actually be improved by adding more of these nodes that are at a 20, 25 foot height versus all the meters that are at the 5 to 6 foot height. The smart street lighting system has a lot of the same functionality, characteristics, use cases as the AMI system. We can get a lot of good data. We can do remote operations for those lights. We can turn them on or off remotely. There's dimming capabilities in the future, improved operations or improved customer service. Customers don't have to call and let us know when lights are out. We'll know right away. We'll even be able to use some of that data to be predictive and say, that light's getting ready to fail, and replace some of those lights beforehand. Obviously, that's the things that the smart street lights can do today, but let's think a little bit further into the future. Let's think about those advanced cases. There's a suburb of Chicago that is working with their smart street lights to see if they can do gunshot detection. So have the smart street lighting hear those things, have an automatic data feed into the public service, and dispatch police personnel whenever they hear those things. Those are some of the things that are going to be on the edge and are going to be in the future. Other things like, we've learned that there's people that perceive that the downtown traffic, 30 to 40% of that are people looking for parking spaces. What if the smart street lighting could actually read between two lines and say that's an available parking spot? Could you imagine our phone actually putting in 180 East Broad and giving us a parking spot right across the street? Those days are in the future, but those days will come. And the last one I want to talk about is a use case that I think is interesting from the city of San Diego, which is they're looking to use those smart streetlights to count how many cars and how many pedestrians go by a location. Could you imagine the economic development for the city or the community to have that data at hand, use that to motivate new employers to move into town? In my view, or our view, those are some of the things that smart street lighting makes available, and it'd be great if we could do that on an existing communication infrastructure that didn't cost us anything to build. So in closing, we look forward to working with the Public Utility Commission on delivering an awesome project for our Smart Grid Phase 2 project. We have a deliverable due to the Public Utility Commission February 1st that looks at the remaining non-deployed circuits and meters where we could put more volt bar, where we could put more distribution automation, and we could put more AMI meters. We look forward to delivering that. We look forward to how that might be the next Phase 3 project for AEP Ohio from a grid modernization perspective. Thanks for your time, and I look forward to your questions.
Scott, thank you very much. We will go ahead and move on to Joe Bentley. Joe is the Vice President, Customer Operations at the AES Corporation. Joe, welcome back.
Thank you, Chair. We're delighted to be back at this second Power Forward Conference. And again, I want to thank Chairman Hawk and Commissioner Trumbull for the invitation today and for this Power Forward initiative. And I want to thank all the commissioners and staff for their vision of the future for Ohioans. We'll be discussing today more about the technology that allows us to achieve a holistic and integrated approach to the distribution system. As we discussed before, I think we have a great opportunity to leverage Power Forward as a platform for economic growth in Ohio that delivers tangible and sustainable benefits to customers. And we look forward to working collaboratively with the Commission and stakeholders in developing innovative regulations and forward-thinking policies. We believe we have the experience and knowledge to deliver those benefits and look forward to the Commission pulling together all the pieces of Power Forward and providing clarity in this initiative. I think you've seen this slide before. We're not going to spend a lot of time on it. But our mission here at DP&L is really providing safe, reliable, and sustainable energy solutions for our communities. And I want to key on those energy solutions. This is really about the customer experience as we go forward. Our service territory includes a diverse mix of both industry and businesses, include military, government, education, R&D, automotive, agriculture, food, among others. Our goal is to modernize our infrastructure in a manner that meets the needs and demands of this growing region. So, our vision of Power Forward centers around these three components, really providing customers a greater experience by delivering new and improved ways of interacting with us and allowing them to make the energy decisions and to access multiple offerings. 2, the implementation and integration of smart devices and equipment and technology that makes the grid more reliable, efficient, and resilient. We believe the tangible benefits of a modernized grid will provide tremendous economic growth for the Miami Valley and for all of Ohio, and those benefits can equate to more than double the amount of investment that we would have in Power Forward. So let's talk, what does it take for the investments to achieve this vision? And really, it's enhancing the customer experience and providing more optionality for them. It's really implementing advanced distribution management system, ADMS, equipment, which are those sensors, switches, monitors, and controls. It is advanced metering infrastructure, AMI, which includes the hardware, software, data management systems, as well as the asset management systems for those, and communication. It's substation and distribution automation as well. But really the secret sauce is really communication that ties all of that together to provide that really integration of all of those disparate devices and equipment to really complete the holistic distribution system and platform. So let's go down into specifics. What does this mean from a customer experience? So customers are looking for the utility to conduct business in new and different ways. We believe that in some respects, that will be shifting the purchasing and services, kind of similar to marketplaces that we have now with things like Amazon and eBay. It also is providing the online monitoring in terms of the portal for customers to be able to access information to make their own decisions. Customers don't want the utilities to make that for them. They want the ability to make those decisions for themselves. It also includes things like electric vehicle charging for the infrastructure as well. That's not just providing the charging infrastructure, but also can be used back to support the distribution system. Currently, right now, we're replacing EV chargers in Indianapolis that allow us to be able to not only charge the vehicles, but access that information with an agreement with the customer to support when there's localized issues on the distribution system today in Indianapolis. It also includes the pushing out of information, so outage information, restoration time, causes, and be able to provide that billing information to that mobile device. Not that they have to come to the website to be able to see what's going on. We're pushing it to their mobile device. And it includes new and supportive and innovative ways for options like prepaid metering. So when we talk about the smart devices, we're talking about those smart switches, reclosures, and sensors that are on the distribution system in conjunction with the substation devices as well. So the gateways to be able to collect that information, the smart relays that sense the problems, and the equipment monitoring equipment. All of that integrated between the substation and distribution, those disparate smart devices really are there to improve reliability, really have that automated restoration and optimizing the resources. So let me give you a couple of examples with that. In terms of, say, understanding the health of our substation equipment, I think some of you may have seen the commercial, the IBM Watson, where the elevator repairman comes into the building and says, "I'm here to repair your elevator." And the guard says, "Well, it's not broke." He says, "Well, it will be in 2 days." That's the power we have with information. It's being able to put the devices out there that allow you to collect the information. But I'll tell you the key component of that is doing the data analytics and the machine learning to really understand that. Because one of the things that we won't have a lack of is information. It's really what to do with that information and how you really identify problems that come out of that. And why do you do that? Because we know right now when you have those substantial failures, number one, it causes lots of outage and issues. And the emergency repair can be double, 3 times the amount of cost if you preemptively do it on your schedule. Another example we just had virtually a couple of weeks ago in Bellbrook. So we've got automated switches on a circuit in Bellbrook, Ohio. And ultimately what happened was the 3 switches automatically identified the problem in Bellbrook, being able to isolate the problem, and between the 3 was able to bring back 500 customers in about a minute and a half based upon that information. So that is one circuit. What we want to be able to do that is deploy that across 6,000 square miles in the DP&L service territory. The next would be advanced metering infrastructure. So we talk about essentially kind of the 2-way meters. In Indianapolis right now, we've had one-way metering since about 2001, and now we've deployed roughly 50,000 AMI meters in the Indianapolis area. What does that do for you? We had a storm 2 weeks ago in Indianapolis. We had 20,000 customers back. And with those 50,000 AMI meters, we've been very happy with the ability for it to provide last gasp information of what's happening in the storm, where the outage is at, bringing it back into our outage management system for us to be able then to deploy the resources to be able to correct the problem. In the past, with some of the one-way meters, what we've had was data collisions. During a storm, when you have lots of customers out, some of those last gasps you don't get as much information. You may only get, say, 10 to 20% of those last gasps coming in. With the AMI meters that we saw 2 weeks ago, a great percentage of those coming back in and gave us really great information during that storm restoration. We talked about the 2-way communication network. I think Scott mentioned it. How do we leverage that AMI infrastructure to actually have additional communication protocol and capability across the distribution system? And we talked about the data management systems. There is a tremendous amount of data that comes in. I'm telling you from what we see in the 50,000 meters in Indianapolis, a lot of data. You've got to really understand what that data is and really look for those opportunities. So data analytics get to be a key of trying to find those anomalies that give you good information. So it's all about customer access to energy information, which really enables really choice and solutions. And then the systems. So you think about the operational systems and integration. So it includes the outage management, distribution SCADA, distribution system modeling, and doing the state estimation. We talked about a lot about volt-var optimization, being able to control the voltage to be able to reduce both energy and demand to save money and to save customers money. To provide that what-if analysis, being able to do that understanding and analyzing when something should happen and do that analysis before it happens and understand how to react to that. And really expanding your GIS capabilities. So we've talked a lot about here's the device, the disparate devices, both on the distribution system and in the substation. Now you layer in the systems associated with that allow you to be able to connect that. And how do you do that? You do it with the integration and operability of the communication, really having the open architecture, having the standard protocols to be able to really connect. This is really the secret sauce because you get great benefits from those disparate devices that you put out, those smart devices. You get it from a lot of the systems that you have. But really having those exponential benefits to customers is really the integration of all those. And that's not easy. And the reason it's not easy because you have a lot of different protocols, some being open, some being proprietary. I'll tell you right now, tomorrow, coming to Indianapolis, we have a startup company that's got, I believe, some incredible technology that allows us to be able to get information coming in from not only the open architecture, but also from those very proprietary protocols as well. I think what we're going to see working with this startup company that we can actually get tremendous visibility from the substation equipment that we have good visibility, the distribution equipment, but all the way to the home to the meter. So we can actually have one holistic ecosystem that we can see. And why would you say, why does that really matter? Because now we have the ability, if you have a failure at a substation, and in this new environment where we used to be, it was a one-way system from the substation to the home. Now you're seeing the integration of solar. You're seeing the integration of distributed resources. Now you have that, what we would call prosumer, and now can you manage those additional resources? It used to be one way, now in a two-way fashion. So if you get that visibility all the way to the meter, now you've got something really special to move forward with. So the other thing I would say is, as Scott mentioned, is really key, is really focused in on the cyber requirements. Clearly, we focus kind of on a defense in depth. Working with NIST, working with NERC, our security folks 24/7 is really looking at and monitoring what's going on, making sure that we protect our information, protect our customers' information, and you do it in a way not necessarily to think about it as an incremental approach. You've got to be thinking about cybersecurity in terms of that holistic approach, thinking about it at the forefront, not thinking about it after the fact. You've got to be thinking about how you plug and play different equipment and how does that really match with the existing infrastructure that you have within the cyber community. So, extremely important point. So when we think about the modern grid benefits, Scott alluded to some of these right now. I mean, when you look at the DOE Smart Grid Investment Grant, documentation, this is coming from the industry. We're seeing upwards of 20% savings on safety at this point in time, which includes and translates to about a 20% impact on safety. We talk about volt-var optimization of, say, 1 to 3%. What we've seen in Indianapolis, it depends whether you get 3%. It depends on some of the equipment that you're installing and also your existing configuration, because you have to understand what's the implications of solar on your volt-var optimization. And so the answer is why? Why does that really matter? Okay? Because at the end of the day, we know that J.D. Powers, the highest weighting percentage of J.D. Powers is focused on reliability, whether it's momentary or whether it's sustained. So if you can make a 20% increase, or increase in reliability or decrease in reliability, you can see dramatic impact on customer satisfaction and the customer experience. And I'll tell you, in Indianapolis, we've seen that. We actually got a $20 million DOE grant. We applied roughly another $30 million on top of that. We're seeing that 20 to 30% savings in safety, and we're seeing the impact. And frankly, it's allowed us in Indianapolis to be a top decile performer in reliability almost year after year in the Midwest, where we do get storms, and having that. So we've actually demonstrated that we can see these kind of benefits in a place like Ohio. Electrification, in terms of what the customer is, we wanted to talk about a little about what we had. We've deployed about 9 megawatts of solar on the DP&L system, and we have 40 megawatts of grid storage. Obviously, I think you know AES is one of the leaders in utility scale energy storage around the world. We've deployed 100 megawatts of solar on the system in Indianapolis. We're actually the 4th largest per capita in solar. We're not talking about Hawaii. We're not talking about California. We're talking about Indianapolis, Indiana. And what you find was, unless you deploy that amount of solar, you really have to understand really the technological components to be able to do that reliably. Being able to we have 20 megawatts of solar at the airport in Indianapolis, okay? That's not easy, and that's not easy to do reliably. We have done that, and frankly, some of the other utilities around the entire U.S. are just now trying to figure out what the technological components are and requirements to do that. We also have 20 megawatts of energy storage in Indianapolis as well. Now, what else does Grid Mod allow us to do? We talk a little bit about smart cities. So you think about the ability for us to be able to deploy smart street lighting. We talked about that a little bit. Fleet electrification. We talk about the ability for data analytics and communication. For us to really use the Grid Mod to be able to help us with smart cities and really help us with the economic development associated with that as well. So in closing, when we talk about moving forward, I just want you to understand that we at DP&L have demonstrated knowledge and experience to implement an integrated smart grid technologies for the customers, okay? We have that experience. It is important to implement an integrated ubiquitous solution that will deliver optimal results to customers. We actually have been doing the planning of this for some time, and we have the elements of that. Frankly, we're using a lot of the framework that we have already done in Indianapolis. It's been tried and true and proven to be able to help develop the plan. Really what we need now is really the direction and clarity from the Commission. We think our Power Forward vision is very consistent to what we've heard from the Commission these days. We want to get the feedback essentially from this Power Forward for us to essentially go forward with that regulatory and policy framework for us to get that direction and clarity. So when you think about combining our distribution knowledge and experience and really the proven technology implementation and integration along with progressive regulatory and policy framework will drive tremendous benefits for customers in the Miami Valley and economic growth in Ohio. So clearly, when you think about this, experience, clarity, and collaboration are those keys to improving lives for all of Ohioans. Thank you.
Joe, thank you very much. We'll go ahead and we'll open the floor up here for the dais up here for some questions. I'm going to start, if that's okay. Look, over the last day and a half, we've talked a lot about, we've done a real deep dive, I think, in some of the technology that's necessary to create the future that we saw in phase one. And so what I'd love to hear from both Scott and Joe is about just where you are with the specifically, I don't know if you got the opportunity to tune in yesterday, but we had Jeff Taft who presented what he believed to be sort of the core elements of platform infrastructure. And so I'd love to hear about that particular piece. And you don't have to be in the same place. I mean, you can be in totally different places with respect to where you sit right now. But you know, Scott, in particular, you said a couple things. I mean, first of all, it appears that AEP is already doing quite a bit of not only on the practical application side that we've been seeing over the last day and a half, but also you have what it appears to be, without peeling the onion, is some significant platform infrastructure in place already, because if you're already pushing sort of some of these end products, and you've got to have that infrastructure in place at least somewhat. Can you talk about where your company sits right now, specifically address the communication system? You feel satisfied that you've got that communication system in place? And let's specifically talk about the infrastructure.
Great. So I can separate it a little bit. So I'm going to talk a little bit first about AMI, and then I'll talk about volt-var optimization and DA together, because they kind of operate on the same platform. So from an AMI perspective, we've partnered with a vendor, Silver Spring Networks, from day one. They provide our communication system. So it's a 900 megahertz wireless mesh technology. The meters talk meter, eventually to a relay, an access point, and then either from there via fiber or via public cellular provider back to our office. We've already built the system in our back office system, so we have the back office system for where all that data comes. So all the meter reads come in. We take that data, we push it over to our meter data manager. That meter data manager has already been built. We're actually already on version number 2 of that platform. So all that system where we take that read from the meter, process it, and send it out to bills, that is already built. It's robust. It works great. We use the same system across all of our operating companies, so it's very robust. It's very well built, and we're very pleased with the communication with that product. We're getting 99.99% of the reads most of the time. And then again, drive it back to a customer experience. Customers don't like estimated reads. So this improvement of making sure that we get 99.9 or 99.9 is a big improvement for them. So again, AMI perspective, the system's there, it's robust. We can add meters as needed with little or minimal investment moving forward. From the distribution side of the world, distribution automation, circuit reconfiguration, volt-var optimization, as I mentioned, we've already built the distribution management system. It's already there. So as we work in one of our operating companies, Ohio, where we're using Schweitzer Engineering Labs for our controllers for DA, where we're using Utilidata for the controller for volt-var optimization, how that data processes through the system, how it's visible, how the distribution dispatchers who actually monitor and manage the system, how they use that's already there. The alarms are programmed, they know what to look for. It's integrated into our outage management system, which gets things routed out to the trucks. It's all there. As far as next steps for that system, as I mentioned in my presentation, the big thing that we still have to do is work on the machine learning part of that. So taking those data points, all that data that's coming into the system from the distribution automation system, and take it and learn how we can tweak and optimize the system from that data. That's a availability in the platform that we built. It's just not been put into place yet. So that's one thing that we're looking to do in the future. The other thing that we're working to do through our existing Phase 2 project is take that outage management information and pull it into there. So it's already there. We can use it in blue sky days. But as Joe mentioned, when you start to have these big storms, how do you program the system? How does all that work? And that's something that we still have a small project to work on so that it's fully utilized. So, down the road, not today, but down the road to where a customer doesn't have to worry about calling us. All that information is readily available from the meter and gets pushed in. So that's something we're working on as well. But as far as everything else, everything is pretty well there.
Okay, so on the communications network piece, and I'm going to absolutely reveal my relative just ignorance in the space and neophyte in the field of grid mod communications here, okay?
Okay.
So we got a presentation yesterday from Mark McGranahan, who gave us all of these different sort of decision points associated with, and also John McDonald went through these as well in the afternoon, associated with the communications network. Some of these decision points were, wired or wireless, private or public or hybrid, licensed or unlicensed. Can you talk? So based upon what you have in place, can you tell us about what of those decision points and those characteristics? What kind of network is this based upon the description you've already provided?
Yeah, perfect. So as I mentioned, the AMI is 900 megahertz licensed mesh. We want to get 6 to 8 reads from those meters per day. The robustness and all those things isn't as critical as on the distribution automation side. When you have an outage and you want those reclosers to talk to a main controller and do some reconfiguration, you want that system to be ready and available. So for our initial deployments, we use the same technology for both those technologies, both for AMI and for distribution automation of VOLVAR. What we've done is some experiments using a different communication system. Joe mentioned when all those outages happen, all those meters are saying I'm out of power. So you can either work on doing a lot of legwork to make sure that those messages don't interfere, or you can end up and build a different system to make sure that it is fully ready, robust, and ready to communicate. We haven't made our final decision for Phase 2 on what we think we're going to do there, but from a risk aversion perspective, having two systems, while it might be slightly more costly, is a little bit more peace of mind to know that when that distribution automation circuit needs to reconfigure, that it does. So if we end up and separate them, which again, I'm not saying we are, but if we end up and do, then you come down to, do you want it to be a mesh, unlicensed mesh? Do you want it to be public LTE, where you're relying on a public carrier? Do you want it to be fiber? Do you want it to be a private communication system? So the way we're leaning, if there is fiber close by where it's cost effective, we would love to communicate over fiber. So as we design the system, that'd be the first and foremost evaluation. Can we get fiber there effectively? If we can't, which would be a majority of the cases, do we want to go mesh or LTE? I think right now, if we had to make a choice, I think it'd be tough. But I think there's a lot of other utilities that are really painting a picture that public LTE option is a viable option. There's also the flip side of that. There's people that say, do you really want to rely on a third party to carry your traffic and those critical needs that I described from distribution automation? My perspective is that's what those carriers do day in and day out. That's their core business, so I trust them to deliver their business. But in the flip side, though, is we could get our own private cellular network, do it ourselves, have the same capability, and have full control. I think that would be valuable. And the company is very actively looking at that. So I think that would be something that you might see from AEP Ohio in the near term.
Okay, very good. You want to, Joe? Did you want to opine?
Yeah, let me start back and make sure I understand. Let's go back to kind of the core platforms, and then I'll go into communication. So I think I saw the slide. I wasn't here, but I think I saw the slide. And what is the core platform, and then how does it kind of layer on top of that? And the way I think about that, what I saw is kind of what was demonstrated as the core, that to me that's the kind of the core utility platform in terms of what we kind of do today. But I see really kind of an integration and marrying of all of those platforms, because really what we want to do is deliver a greater customer experience to the home. And to me, that includes really the integration from the substation along the distribution wires to that meter at the home. So to me, when we think about the core platform, I think you have to have that ubiquitous, holistic approach where you integrate all of those devices along. So what I saw was the core, what I say utility, kind of prior utility core. We're really good at the substations. We're really good, delivering the poles and wires. But to me, really delivering that in-use customer premise solution, really providing that really advanced opportunities for customers, you got to get to the meter. And that's, to me, you've got to integrate all of those. Now, as it relates, I think the secret sauce is the communication. We clearly have an opportunity and a really good communication at the substation level, so great fiber connecting that, getting 4-second data coming in for our substations. As Scott alluded to, as we think about something like AMI that allows us that communication, I'm not sure I care what the wireless solution. I think it's looking for the best solution at the most reasonable price. And Scott pointed out, there's going to be times where you will get fiber closer to the home, but when you're getting kind of to the last mile potentially, you may have to utilize, and probably will be utilizing, wireless solutions. What I want to have those in-use communications robust enough to deliver that AMI data back so that we can actually provide that to customers, provide those solutions. So having really the interconnectivity of the communication system alone, it's not just the devices. So I want to be able to have that handoff from fiber to a mesh network, to maybe some actual public telecom opportunities. I really don't care what that solution is, as long as that entire ubiquitous communication allows me to get to that information at the customer premise. That make sense?
Yeah, is it fair to say that each of the EDUs is going to have its own preference and also its own, based upon just where it's situated and its footprint is situated, its own capabilities for the communication network?
Yeah, that's one thing I wanted to elaborate on. So, we may come up with what is our preference on how to solve the telecom connectivity for the smart grid systems, but it's not cookie cutter. Yeah. It's not one size fits all. We put a distribution automation circuit in a very rural location. There might not be public cellular there. We may end up in, let's say we go down a path where we're purchasing our own public or private LTE service, and we try to do that circuit, and we have to build a whole new tower. We end up and may say, well, we don't want to do that. And we would go back to the unlicensed wireless mesh system. So those are kind of some of the things that we'll have to look at. So for our service territory, AEP Ohio's, we're getting cellular coverage from the public carriers at about 75% of our service territory. So 25% of the service territory, that's just not going to work. So those are some of the things we have to do. We'll come up with a preference. We'll come up with a solution that makes best sense for our utility. But it's really going to be a design as you go, a design to fit based on the geographic circumstances that you're in. So I think that kind of answers your question.
2 more topics I'd like for you to address, please. So the first surrounds the concept of standards. We've heard about standard. We had a good conversation about standards yesterday. It came back up today. Standards play into this concept of future-proofing your investments. Mm-hmm. In developing this infrastructure, in developing your communications network, have you adopted any standards that are available for public consumption? Are they your own standards, or what do you utilize?
So again, we've created 29 distribution standards for distribution automation and volt-var optimization. Those are internal standards. Those are what we use to design on. That's how they factor into our system. Everybody's system's a little bit different. But as I said in my presentation, we are very active in trying to be as involved with as many different groups as we can. We want to share our input. We want to help guide those conversations. But ultimately, when you look at kind of the standards you're talking about, industry-wide standards, those are things that every utility should be stepping up and trying to provide their insight. And those are going to be a little bit higher level. And then when you take those standards and you apply them to your utility, you're going to lock in a little bit more on what your specific needs are. So you'll take these as a big umbrella and you'll have them fit for your utility. So I think that's really the key, is involvement in all those different activities.
Joe?
Yeah, it's really having those industry standards, whether it's the Smart Grid Interoperability Panel, whether it's NIST. We really want that, the industry and technology suppliers, providing those standards for us, because ultimately at the end of the day, I don't want to have to go to a startup company to be able to get information out of a proprietary system. I don't want to have to do that. It makes it easier if I have that holistic view across the distribution system. So the more that we have standards to be able to rely on, the more that we don't have to worry about having to get information out of those proprietary protocols. So absolutely.
Okay, very good. Last question, and this sort of, so did you have something to add?
Well, I
to
was just
this,
going to follow up, if I could. So think about, like, we end up choose a provider for our distribution automation controller. Obviously, you're going to have a regulator vendor as well. Could you imagine where there was a world where that controller only worked with one recloser?
Yeah.
What happened if you have that recloser company provide you, bad service, they've run into an issue? You want to have plug-and-play opportunities to replace that recloser with whoever's recloser. So I think that's the key there, is giving the standards the ability to just have plug and play. You can take one component that's not working, you pull it out, and you put another component in. It's set to these standards, and it ends up in work. So I think that's our key objective.
Okay. Last one, I think. Let's have a conversation about data and where your companies sit. Effectively, where they, boy, how do you couch this? How do you house your data effectively, and who has the capability to obtain that data?
So as of today, all of our IT back office systems, in previous lives, we were to go get data right out of the individual system. And what we found is that's not a good, reliable way of getting data. So we built a data store effectively. So a separate component where all the data is housed. That way, if you need something, you can go to one source, you can pull that information out and use it where you want to. A good example is for the web portal. We take all that AMI data. We don't go and get it right out of the AMI back office system and put it on the web. We go to the data store, pull the information out of the data store, and put it up there.
Okay. Joe?
So we're housing that data right now similar to, actually, it's essentially we're providing our own storage for that. But I'll tell you kind of not a funny story, but it is kind of humorous at times. In Indiana, we had a situation with those 50,000 AMI meters. We get to the point where we've got so much information. It's how do you really store that information? And one of the things we've identified is that, what do we think about that storage in the future? Because ultimately, at the end of the day, do we really want to be doing that locally, or given the fact of what Amazon, what Google is doing in terms of the data in the cloud and that capability, do we think about having, at some point in time, migrating that? Now, you then get concerned about what are the cyber requirements, what's the ability to protect that information, but there's tremendous amount of energy around this day of having the ability to be able to really collect, because I'll tell you, the information we're coming out of AMI meters is the volume is incredible these days. And one of the things we found is you got to collect all that and really start the data analytics and machine learning, which we've started right now, to really look for those anomalies. So if you don't capture all the data, you really can't drive the benefits for that. So right now it's stored locally. We're actually looking at where should that data reside ultimately at the end, and is that cloud an opportunity for us in the future?
As Commissioner Friedman has pointed out, I think yesterday, this data becomes extraordinarily important to potential application vendors, and so I think there's probably another discussion to be had about accessibility and willingness to provide data and compensation. Compensation rubric associated with that. I think we'll probably save that till phase 3, but I think this is very likely an important piece to the puzzle as well. Okay, Commissioner Trumbull.
Hi.
Hi.
Yesterday we talked a lot about OT-IT convergence, and I guess I was just curious on your view within your companies, what you're seeing in that regard, that this is something that the industry is finding to be more and more prevalent and important as we move forward in grid modernization. So if you could talk a little bit about that.
Can we start?
Sure.
So I guess the way I think about that is that when you think about the operational systems, really the OT side, I want to make sure that as you move forward, you put the priority where, in my opinion, where it needs to be. So if you think about, the operational systems for us to monitor and control our transmission distribution system is paramount. Okay, some of the relative IT-related functions per se are not as important to me. Now, and obviously some of my other colleagues, and they think that's important, but really operating the system is important. For me, as long as that IT-OT convergence really is done right, I don't really care. What I want to make sure is that it doesn't create a silo that you can't effectively communicate across those. So at the end of the day, I'm kind of biased. I like to see the operational because I think it puts us more in priority. But as long as the convergence between IT and OT is done right, then I'm somewhat indifferent to how that convergence actually happens. Make sense?
Yeah, so is that going on right now in your company? You see that happening?
Yeah, we're actually kind of looking at not only within DP&L, but we think about that across the entire AES platform globally. So we're talking about what does that really look like? But clearly, at least in our business, we're really focused to ensure that the OT are getting the priorities that we need and not get clouded with some of the other business-related functions. But as you think about data, then they tend to converge back. How do you manage data both in the OT and IT sides of the world going forward? But clearly making sure the operational technology side, really running the system, has the priority.
Okay. Scott?
I've got a real life example I'd like to share. So, and it hits right on the head on the OT IT. So right now in the old world, Recloser has a control on it. That resource that goes out there is what we call meter revenue operations employee. They have antennas now in these controls. Well, that requires a telecom operational employee to go and work on that. So if you could go work on that control, you could end up and have both those employees standing there working on the same device at the same time. Why would we want to do that? So we as a utility have already said, okay, that's definitely opportunity number one. Let's work to migrate those two workforces into one position. And let's not focus on whether it's IT or OT. Let's figure out what needs to be done. What's the workload there? And let's assign a single resource to get it done. And what we're finding is this is probably going to happen everywhere. It's transitioning a lot of these, what I'll call more manual workload into more high-tech workload. And finding the right resource, assigning clear responsibilities is really the key, not what they're called, in my opinion.
Thank you.
Okay. Commissioner Johnson?
Mr. Chairman, thanks, Joe and Scott, for coming before us, and we appreciate your presentations. I've been thinking about this the last several months about how we communicate with each other, and and even with the commission. It is a little bit. This is the way we've operated. There's lots of lawyers, and I like lawyers, and a lot of all these people are saying things. Commissioner Trumbull, are you down there? Okay, but anyway, that aside, I really do appreciate. But I wondered about the communication that we had with each other, the other utilities, or particularly the other two electric utilities. And I know you see each other at different events. I know that it sounds like cybersecurity, that there's really been an effort there maybe to work together. And I wondered if, it seems to me these are somewhat unusual times. Joe, you mentioned about moving forward, and Scott, you did too. And it seems like this is an unusual time, and I wondered if there's a need, or if I'm just missing out on all the times that you guys work together on the future for the consumers that we have in Ohio. And, you know, from our perspective, we're thinking about all Ohioans. And do you have any comments on that?
So yeah. So let me tell you that we do work together. In fact, I'm on an EI committee, at least at that point in time that Duke and AEP is on. Actually, we meet in a couple of weeks in Seattle. It's centered around strategy as it relates to kind of, it's got a smart city, but it's really more about technology. So actually sit on that advisory strategy panel for EEI with AEP and Duke. But I'll tell you, this will come, you know, I think there's a greater opportunity. I think some of the past of things not necessarily in the poles and wires business have really kind of fractured some of the relationships maybe between the operational folks. And I think there's an opportunity. I think as you heard Scott and myself talk about kind of our visions of how things are going to be, they're in a different state than I am in Ohio. I'm actually probably even further ahead in Indiana. So I think there's an opportunity for us to really share between the EDUs in Ohio. But I think it's some of the past non-related kind of transmission distribution that has kind of clouded that. And I actually would love to work more collaboratively with my colleagues in the state, because I think we see things very similar. And I think it would be interesting for us to form a better relationship going forward.
I think it'd be great.
Conversely, I would like to see like an arm wrestling tournament, like an Over the Top, the Sylvester Stallone movie. Have you seen that one?
I'm going to delegate that. I'm going to
Okay, yeah,
volunteer somebody, one of my big linemen.
Right, right, very good. Commissioner Johnson, anything else? Okay, Commissioner Friedman?
I won't ask a data question, thanks to the chairman's reference. Joe, you mentioned Indianapolis 7 or 8 times, if I was counting correctly.
Right.
Scott, you guys are in 11 different states, I think?
That's right.
And you didn't reference where you are in other states relative to... That's okay, Dan.
We're getting punchy past hump day.
Notwithstanding
We're
the
getting punchy past
slide, I was going to ask you, based on your experience in this and other states, and this will apply to both of you, what haven't you done that you would like to do in terms of grid modernization that is new and different? Not more of the same, but new and different. Do you have thoughts?
Yep. So 2 of our operating companies are currently exploring distribution line sensors and how that plays into distribution automation, how it helps you get more visibility in where outages are, where your issues are. That's something that as they work through those trials, realize what the benefits are as compared to the cost. I think it's something that we will very actively pursue in the near future. Again, I want them to kind of run through their whole experiment first. Again, we're always focused on, you know, not the technology, but what is the solution for the customer, and understanding how much benefit is there as compared to the cost. If it proves to be beneficial, yeah, we'll definitely, we would definitely look to add that to our portfolio.
Yeah, and I would say we're not far enough along, but I think it really is focused not on the devices per se. It's really the data analytics and machine learning. We've started working kind of pilot programs right now to really capture that AMI data in Indianapolis and looking, because it actually requires a different skill set. Because if you think about the amount of data that we're getting, you really need data scientists, because what you don't want to have is an engineer getting all this information and assume they know what the problem is. What you really need to do is amass all this data and then look for anomalies. And don't try to prejudge what the issue is going to be. Look for the anomaly and then go interrogate down and understand what's going on. So I think you're going to see more data analytics, data scientists, whether you contract some of those resources or whether you embed that in your existing organization as you go forward. So that's going to be an area of focus. So in my asset management group that's focused in on really managing the assets, understanding the health of the assets. We're actually in the process now of hiring essentially 2 data scientists to help us really understand. Because the good thing is we're getting the information. The bad thing is I'm not sure we know exactly what to do with it. So I'd say that's the next step for us.
What other platform infrastructure pieces do you need? So actually, let me direct that question at you, Scott. What other platform infrastructure pieces do you need? Do you feel like it's generally speaking all there?
Yeah, I mean, it's generally all there. I mean, I think if you kind of turn the corner and talk a little bit about smart cities, and there's some additional platforms that would be needed there. But yeah, for a smart grid, I think we've talked about it all.
Okay. And Joe, you guys are in a different place
That's right.
right now. But outside of I think you're at least the AES Corporation has some experience in Indiana and has an understanding and has an idea of the infrastructure needed to create the modern grid platform.
Yeah, so what we need is really that robust communication platform, whether it's a mesh network in terms of, a Silver Springs or Landis+Gyr mesh network, or whether, it's actual public telecommunication. We need that robust communication, likely going to be wireless more than to deliver to 6,000 square miles in Ohio. That's what we need. And we've got a really good communication system in terms of the substation side. We now need to connect to the last mile, and in whatever form is the most cost-efficient way and robust to do that.
Yeah, let me ask one last question associated with the cost efficiency piece. And this is actually, I'm actually playing off of Tom's question, which is Commissioner Johnson's question, which is, look, so you are in different stages of development of this platform. You have, arguably, AEP Ohio will have a communications network or other components that may be different than what DP&L's ends up looking like or First Energy's ends up looking like. And so one concern that I have is that, the applications that are born from your individual company's platforms will purely be applications that can exist on that particular platform as opposed to potentially enjoyed statewide. So is there any commentary on that? I mean, since AEP Ohio, it feels like you guys are out of the gate and you're running down the track here. And so any thought behind, of course, if there is a willingness to allow for others to provide applications and play in the space, concerns about statewide compatibility?
I don't think there are any concerns. I mean, I think generally, recently we hired an individual that has a non-utility background. We brought him on board. He was simply amazed at how well utilities work with other utilities to solve common problems. And I think that's really what you're getting down to. A good example is some of the AMI use cases to solve, using data to solve problems that we've already learned, we've shared with others. And vice versa, there's been use cases that other utilities were ahead of us. There's a use case in ComEd that they shared with us. So I think really that's the key, is making sure, back to, the previous question, is that, we're all out doing the same thing. We're all out trying to help our customers deliver these new grid modernization technologies. I think we just need to stay focused on working together, and I think that's really the key to get that solved. In my opinion.
Great, very good. And per Commissioner Johnson's suggestion, I think it would be wonderful if we could all collaborate and keep each other abreast of these various components that are being built upon. The problem is that, again, we're a little out of our element here, right? So, if your communications, if the communication component of your platform is if they're all different from each other, and then you continue to build upon that platform on the application end, will the application that works, are you able to mechanically, are you able to engineer this so that the application that goes into your system is the same, or it can plug into your system as well?
Well,
right?
I
And
mean, in
think-
some cases, you can't just pull it right out and give it to them and they can use, but you can share your perspective on how you got there. So here's what we did, here's what we found, here's the ultimate solution, and then they may say, yeah, we like that, and they go build that same thing on their side. So where they're not going all the way back to, square one, but they're getting some insight on what it took to solve it. I think that is the key for when the systems are different.
Thank you. It dawned on me that I don't think I have asked if you have any questions, Commissioner Conway. by just listening. No. You have not waived your right. Go ahead, please. Christina waived her right as well. No, you go ahead.
Not much of significance, I don't think, but I was trying to follow, Scott, your explanation for the potential for different communication paths necessary to support the distribution automation circuit reconfiguration function compared to the AMI function because of either interference from one to the other or temporary disturbances that highlights the need for a higher degree of reliability with the distribution automation side so you can work it and allow it to do its magic. And then I didn't quite, Joe, get the sense that you were on the same page or not the same page, but that you had reached a similar kind of decision point, quandary point as Scott had. So the first question is, did I understand you correctly, Scott, that was something you were mulling over? And if so, is it possible that you're going to have more than one communication channel, or if not network? And then second, so that's the first question. The second kind of relates to it, which is when you get to a decision point like that, when you're doing your planning internally, do you the robustness of your internal discussions about it, do you use something like what we've heard from, I think, the GE representatives here and elsewhere, and I'm sure other companies do it, the red and blue team approach, where you have some kind of check on which way you're going by, critics that you bring on board to give the counter case for doing something other than what you're leaning towards. So first question is, do I understand the communication network, system issue correctly, Scott? And secondly, how robust is your internal discussion about the choices that you make?
Yeah, so let me explain it a little bit differently, and hopefully this makes more sense. If you have this big pipe that you're trying to send this communication down, and over here on the left, you have AMI traffic that you want to get into that pipe. At AMI traffic, and an outage is saying, hey, look at me, I'm out of power. And those, in my opinion, are lower priority, and they're trying to get into that pipe. Over here, you have your distribution automation circuit reconfiguration. The recloser is trying to talk to themselves and trying to reconfigure so I don't have an outage for a large group of customers. Obviously, that's much more important to us. So you have both these things feeding into a pipe. So what you have as an opportunity is evaluating your pipe. Can you make your pipe bigger so more gets through, so it all goes through? Can you take your AMI traffic? Can you slow it down so that it doesn't impede with the recloser traffic that is talking first? Those are all conversations that we can have, and we can try to make the two systems work well together. That's option one. Option two is we can say, let's not worry about that. Let's have two pipes. We'll have one for AMI, and we're going to have one for distribution automation. That way we know all the DA communication gets through the pipe. So that's the decision that we're at. And we haven't made the decision whether we continue to work on one big pipe or we work on two small segments. So that's what the decision is. And ultimately, I don't know where we're going to go with that, but I would say that there's more of a propensity to make sure that we don't have that collision. It's less risky to go with two pipes than it is one pipe. Does that make sense?
Yep.
Thanks.
So my response would be, you're going to have multiple communication. You're going to have fiber. You're going to have wireless. Some of that's going to be potentially public. Some of that's going to, you're going to have a variety of different communication, because ultimately trying to do is you won't need fiber. You won't need that large pipe, necessarily in every application. What you really want to do is be able to make sure that you have what you need based upon the information that's coming through, and you need to be having the forethought of what that information is going to be in the future. But I'll tell you, the telecom and communication guys have done a really nice job. I don't think you necessarily these days need 2 pipes. I mean, the pipes are very robust to begin with. What you need, and they do it very well in terms of prioritizing the data packets. Okay, so at the end of the day, if it's a situation, it's billing information at the customer premise, I don't need that, within 10 cycles, okay? I don't need that information. It's sitting there at the meter. I can go get that at some point in time. So making sure you prioritize the data packet. What I do need is I've got an outage. I've got to get that reclosure, essentially isolated and get the back-end reclosure closed to pick up those 500 customers. So prioritizing those data packets to ensure that the most important data is getting through, as well as at some point in time we can go get that billing information.
So you're his red team and you're his blue team. Okay.
Okay, thank you. Christina, anything? Okay. All right. Scott, Joe, thank you very much. Wonderful presentation.